Let's go. We are finally at loops. This is going to be super easy because Java and Python are so similar. First, I'm going to stop, go right to NetBeans, and I want to make my Chapter 5 notes. I've already typed in the title, remove the package. Here we go. And let me get rid of this. And we are going to show even some NetBeans shortcuts. Both Java and Python have for loops. Both have while loops. Java gives us a do while loop, which can be sort of helpful. It can be cool when you see its value and see its purpose. The difference is simply the syntax and other small nuances. So some reminder on terminologies. We have definite loops and indefinite loops. Maybe you haven't heard that term before. A definite loop is a loop that will run a very specific, a specified, or a definite number of times. They're implemented using loop counting control. Whether you had a while, whether you had a counter-controlled while loop, or you had a for loop, which is pretty standard for definite loops, these exist within that category. The indefinite loops, those are loops that will loop an unknown or an indefinite number of times. When you iterate until the user maybe says, I've had enough, I don't want any more. So it's an unknown number of times. Those are your standard while loops or your do while loops that we're going to see. So let's jump right into comparing. Python and Java. Here's a for loop. Java looks almost cryptic in comparison at first due to the extra syntax. Python, for I in range 10, this would be the identical loop in Java, and all we're going to do is print that loop variable I in both of them. So a reminder though, for Python, our range function, we have up to 3 different parameters you likely recall. If we have one parameter, just this 10, that means that we're going to loop up until I equals 10, but not 10. And we start at 0 by default. If we have 2 parameters, such as range 5, 10, that loops starting from 5, not 0, and then it's going to loop once again up to 10, but not including 10. And then finally, a third parameter means that the number 2 here is the step size. So we're going to loop from 5 up to 10, not including 10, and we're going to step every 2. So that looping variable I would get the value, on this example, it would get the value 5, then 7, and then 9. And when it goes to 11, that's past the range of 10, and so the loop would stop. Why is that important? And here's the details of that reminder from Python with the range having 1, 2, or 3 parameters. So why is this important? Because in fact, Java's loop, for loop, is most analogous to Python's 3-parameter range function. And it gives you full control over the start, over the stop, and over the step size. So if you look at this Python example, for I in range, start, stop, step size, and then we put statements inside the loop. That would be analogous in Java for, and notice we have 3 parts in here. We have the start clause, we have the stop clause, and then we have the step clause. And of course, inside the loop, we then have additional statements inside the loop. So they're analogous in this way that the 3-parameter range function of Python is most similar to Java's for loop. And now let's look at those details of Java's for loop. Here's the precise meaning. We have the 3 parts. That first part, which I called here the start clause, it's really the initial actions. Whatever initial actions you want to take before your loop executes. This second portion we call officially the loop continuation condition. This is the condition to check whether or not you should continue running the loop. And then the final portion inside Java's for loop is the action after each iteration. And it's literally what that says. That is the action that you will take after a single iteration. And so coming back, let's now look at some examples. Here we have a Python for loop with the 3 parameters. For I in range 0, 10, 1. So we're going to loop from 0 up to 9. And the step size is going to be 1, right? So we're going to loop over 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In Java, notice the highlighting in the colors. The initial action is what we called it. The initial action, that first portion in the loop, is where we're going to initialize our loop variable I, and we initialize it to 0, and we also have to declare it if it's the first time we're using it, and usually that will be the case. If I come here to NetBeans, check this out. If I just type in FOR, I type in FOR tab. Let me do it quicker, because if I do it slow, there's many different types of for loops. If I just type in FOR tab, well, let's see, let's try that again. FOR, I could come choose the one. It's really this one right here, but I was hopeful. Normally, if I just type in FOR tab, nope, maybe they've reordered them in NetBeans. So because what happens, there's so many different for loop code completions available for you, so this one happens to be listed first. Long story short, if you type in FOR, you can then select right here the option. And it now says int I equals 0. So this is our initial action. We're declaring this I variable. We're setting it equal to 0. And then what follows is this I less than 10, which is the loop continuation condition. Keep running this loop so long as I is less than 10, which is what Python does here. And then the step size is 1. And here in Java, this is the action after every iteration. After one iteration, what do we do in Java? We increment I. It's that simple. It's that simple. And so I'm merely going to print I right here. Let's loop to just 5. From 0 to 4, I run, and we get the output we expect from 0 to 4. Super simple. The next one, because this is 3 parameters, I can change the values. What if in Python I said, let's go for I in range 10, 101, 5? What will that do in Python? It will loop starting from 10. It will loop up to 101, but not including 101. And by multiples of 5, a step size of 5. In Java, same thing. The initial action is to declare this variable I and set it equal to 10. We're going to continue looping so long as I is less than 101, but not equal to 101. And then finally, we're going to increment I by 5 each time. Now notice the difference from the previous example. Here we had I++, because that's incrementing by 1. But now since we need to do a step size of 5, look at what we do. We say I plus equals 5. How simple. Go from 10 all the way to, let's go 10 to 20. But it won't include 20. And let's do a step size of just 2. So this will print 10, 12, 14, and so on, 16, 18, but it won't print 20 because I stopped at 20, and it's not inclusive. It's less than 20. Now I'll make it less than 21, and it will go up to 20. Or I could have said, as you know, I could have said as long as I is less than or equal to 20, same thing, that will work as well. Super simple, right? Because it's the same concept. Python, what if you wanted to count down? We could start at 10, go loop down all the way until we get to -1, but not -1, so it's not inclusive. It'll go down from 10 to 0, and we're going to step down by how much each time? By just 1. And here's the Java. I'll make a new for loop. We'll start at 10, and we want to go all the way down to -1, but not including -1. We want to decrement every time because we want to go down by 1. But notice, what is the condition now? We want to keep looping as long as what? Just say it in English. As long as I is greater than -1. Just think of it in English and now make the code. As long as I is greater than -1. So you notice that, of course, we change from a less than to a greater than because the logic of what we're trying to solve changed. So now when I come run this code, sure enough, if I just print I will get exactly what I'm expecting. 109876543210. Perfect. And this looped all the way from 10 down to 0. And we have one more, looping from 100 down to 49. by multiples of 5. Same thing in Java. We declare and initialize this variable I to start at 100. We keep looping as long as it's greater than 50, inclusive of 50, and we decrement I by 5 each time. Also, we have in Python where we can loop over a sequence, such as a string or such as a list. And you've seen this in Python. If we have a list called values equal to 1, 2, 3, 4, 5, a list of those 5 values, I can do a for loop and say for val in values, and I can loop over each one of those values in the list. And what really happens here is we're taking one at a time, we're taking this value out of the list, and we're not out of it, but we're accessing this value and we're saving it into the variable val, and then we print val. And we're doing the same thing for 2. We're taking the 2, saving it into the variable val, and then printing val. And we do that for 3, 4, and then 5. Java has a very similar functionality with what is called or known as its for each loop. What is a for each loop in Java? Well, here we have an array. What is an array? That's going to be coming soon. Think of an array for our purposes at the moment as a list. And here's how you would declare an array. And inside this array, we have 5 values, those same exact 5 values. And if I didn't give any explanation, it's pretty clear what's going on. Instead of having this word in, we have a colon. And what did I say? We're taking every single value from this list and we're saving it into a temporary variable called val. Well, every single value from this array of values is being saved into a temporary variable in Java called val. The difference is now we need to declare that variable as an integer. That's it. That's the difference. How simple and how easy this is. That's for definite loops. Now we're going to get to indefinite loops. Indefinite loops, as we said, are loops that we don't know how many times it will iterate. This is our while loop. And look, what do we see between Python and Java for while loops? A colon is missing. For Java, we don't have that Python colon. And then in Java, we have parentheses and we have curly brackets. It's that simple. Everything else is the same. Also, Java gives us a do-while loop where, and we'll talk more about this now, in this do-while loop, notice here on the while loop, the condition is at the top. Before we execute the statements, we check the condition and then we execute the statements. For a do-while loop, at the top, we simply say do, and we do the entire loop one time. And then after that loop finishes, we then check the condition and determine, should we do it a second time? This is a do-while loop in Java. And really the purpose of a do-while loop, it's not a big deal. You don't need a do-while loop. Clearly, Python does not have a do-while loop. But the value of a do-while loop is what? If you have a situation where you know for a fact, I absolutely need to iterate this loop one time, no matter what, and then afterwards you can check the condition to see if you should do it a second or a third or a fourth time, that is precisely when we use a do-while loop in the value here. All right, what's next? Common mistakes. And we've already seen a lot of this, where on selection statements after the Boolean expression, after the parentheses, new programmers to Java, new developers will be putting a semicolon after the Boolean expression. That's also a common mistake for new developers in Java with for loops. So absolutely, you do not put a semicolon at the end of the for loop before even starting the body of the loop. You do not do that. You also do not just put an empty body. That would be an error. And the same thing would go for a while loop in Java. After the condition of the while loop, or after that 3-component portion of the for loop in Java, you do not put a semicolon. You merely have a starting, opening curly bracket to start the body of the loop. And finally, I think this is the final thing. Yeah, finally, we have break and continue. And break and continue work precisely as they do in Python. So if you know how they work in Python, then you are golden. How does a break work? As a reminder, a break will break you out of the loop. It will terminate the loop. Think of this similar to breaking out of a switch statement, since we've learned switch statements. Continue. What does that do? That will end the current iteration, and you can think of it as continuing to the next iteration as long as the loop continues. So what I also say is, while break will break you out of a loop, the keyword continue, or the command continue, will break you out of that iteration. And what happens is you go to the end of that iteration, and then you check, does the loop continue? If so, we'll continue to the next iteration. So summary, break breaks you out of the loop. Continue will break you out of the iteration. That's it. 15 minutes. We're done. What follows is practice. So I'm going to solve some problems here live so we can see how we would actually go about doing this in a variety of different ways on solving these problems. Program 1, addition quiz. Let's knock these out as quick as possible. Write a program to simulate an addition quiz for first graders. This quiz should have 5 addition questions. For each question, you should randomly generate 2 numbers from 0 to 9. Each program should display a message after each question. Your program should display a message after each question and should calculate the results. Here are some sample runs of the program. I'm going to come over here to NetBeans, make a new project, call this addition quiz. Let us remove the package. Done. Pardon me. And let me zoom way in so it's clear for you. All right. Let's now look at the samples to figure this out. And I encourage you to actually pause the video and try to solve this. From the samples, solve it. You know you need a loop. You know how many times you need to loop, right? Think about that. How many times you need to iterate? 5 times. What needs to happen at every single iteration? We need to generate 2 numbers at every iteration. We need to ask them the question. We need to scan the answer. We need to print, is it correct or is it not correct? We need to print the question number. A lot's going on. We need to save if they got the answer correct or not, because ultimately we need to then print these results. Let's go. Yes, let's go. Come on, we got this. Here we go. First of all, we need a scanner. Scanner, n equals new scanner, system.in. You need to import that, Java or NetBeans. Sorry, we'll do this for you. So let's import, done. What else do we need? We need to generate 2 random numbers. We'll do this a couple of times, but a couple different ways. But for now, let's do it the standard way we know of. So int num1 equals int math.random times 10, because we said we want it to go from 0 to 9. You don't want to type that again. Copy paste is your friend. Num2. Now this should be in a loop, but right now I'm not even doing a loop. I'm just going to do this one time. This is a loop design strategy I'm going to cover shortly. I'm generating 2 numbers. I need to ask the user that question. So what is the question? I need to put the question number, so I'll just print 1 for now. 1 space, 1 period space, and then I need to say num1 plus a plus sign. This is horrible without formatted printing. Plus, and then we need to get num2 plus the equal sign. Is that right? That is perfect, I think. Let me run this to make sure it looks good. 3 plus 5, for example. 3 plus 0, yes. 7 plus 3. Fantastic. Now we need to scan the user's answer. So I'm going to say int user answer equals n.next int. Done. I'm also going to calculate the correct answer. So int correct answer equals num1 plus num2. That's not necessary, but it'll make it a little bit cleaner perhaps. And I'm going to simply say if user answer, if I can spell correct, if user answer equals the correct answer, we want to do what? We want to print correct. And that's going to be 1, 2, 3 spaces over. 1, 2, 3, correct. Else, we want to print 1, 2, 3, incorrect. So let's see how this works. 9 plus 3 is 12, correct. Perfect. Let's do an incorrect one. 8 plus 5, let's call it 12, which is incorrect. And that's exactly what we want. Nice. So here we've done it once. We've tested it. We're getting different random numbers. It's working for incorrect, correct. We need to loop how many times? 5 times. Well, check this out. I'm going to highlight all of that. I hit cut, FOR tab. It worked this time. I typed it fast enough. Because if you go slow, FOR, it thinks you want this first one in the list. But it's really this one right here. But notice it populates this for us. I want to loop 5 times. I could go from 0 to less than 5, but I'm going to go from 1 to less than equals 5. And you'll see why I'm going to do that. And now I'm just going to paste inside here. My spacing is funky, no problem. Alt-Shift-F to do my auto format. And now that I've done this, let's see, what else do I need? If I run this right now without even thinking about it, what's the problem? 8, correct. Now it prints 15, correct. What's the problem we see? That the question number is always 1. That's a problem. So we need to print the first time, this needs to be question 1. Then the second time, question 2, then question 3, and so on. So how could we do that? Well, here I'm printing 1. Instead of printing 1, what could I print? Some of you are probably shouting at the screen, print the question number. Like I'm already looping 5 times, I may as well let that be the question number. So I'm just going to put right here, I plus, and then I'm going to concatenate a period space afterwards. And just with that one change, what do I get? Done. It's exactly what I wanted. 13, let's miss a couple, let's call this 7, let's call this 5. So that's exactly what I want. I ended the loop. After I end the loop, what do I need to do? I need to print quiz results. Also, before then, I notice I have a space after the correct or the incorrect, right? It's not just printing correct, it's printing correct and it's printing a new line. That's an easy fix. Put a new line here, put a new line here. Done. Let's check that again. I'm just going to put in some bad answers. Perfect. I went too fast. Let's run that again. Good, good, good. That's exactly what I want. Next, we want to print the quiz results. Quiz results. You correctly answered blank out of blank questions. Perfect. So we want to print, and it was indented 3 spaces. You correctly answered. We have here 4 out of 5 questions. Period. I don't know why that went blank. Period. Okay, 4 out of 5 questions. Done. So now, after that we've done this, we need to, of course, we can't just say it's always 4. How are we getting that? Well, we need to keep track of the questions that we've answered correctly. So we need a variable called numCorrect. So I'm going to come up here, int, and you know what? Before I even do this, I want to it's not good, it's not ideal every single iteration. Notice I'm declaring another num1. And you might think, hey, I thought you told us we can't declare x and then declare x again. You can't. But because it's in a new iteration, it's in a new block of code. So check this out. This is funky. If I just did this, there's no reason to do this, but if I did, if I said int x, that's not in a loop, but that is a block of code. And then I do another block of code, I can say int x again. These are 2 different variables because they're within their own unique block of code. And in fact, they're not known outside of that block. Let me make this A. Let me make this A. And so here, after that block of code, if I say A equals 4, Java's going to say, excuse me, I don't know what A is. This has to do with scope. Hopefully we remember scope of a variable. The scope of a variable is the area of your program where a variable is known and understood. And the scope of a variable always starts from where that variable is declared until the end of the block that variable was declared inside. So the scope of this variable here starts, the line is declared on line 9, but it ends on line 10 at the end of that block. Same thing for this variable. What does that mean coming back to loops? What that means is the scope of num1, well, it's understood the scope starts here on line 10, but where does it end? Well, it ends at the end of that block that it was declared inside of. Well, so we click this curly bracket, so it'll highlight it for us. NetBeans highlights right here. That's the end of the block. So the scope of num1 ends right there, and on the next iteration, we make a brand new num1 variable. Maybe no harm, no foul, but it's better to say, you know what? Let me declare all of my variables that I'm going to be using at the top up here. Num1, num2, correct answer, user answer, and even count correct, which is what I needed. I'm going to initialize that to 0. Recall, I need to keep track of how many are correct. Now I get all kinds of red lines now because NetBeans is saying, hey, you've already declared num1, num2, count correct. So let's go delete those. And we delete these. Done. Those are now deleted, those declarations, because I've declared them all up top. I also declared this variable count correct equal to 0. I started it at 0. I don't need to start these others at 0 because those are going to get values during execution of the program. Count correct, though, I want to add the number of correct answers, so I need to start at 0. So if they answer it correct, I'm going to print correct, and I'm going to count correct plus plus to increment the number of correct answers. So now I can say, you correctly answered count correct out of 5 questions, and we need to even give a score. This will be fun. Print 1, 2, 3. We indented 3 spaces. Score colon space. All right. How do we get the score? If they answered 4 out of 5 correct, that'd be 80%. So how do we get that 80%? We take 4, we divide it by 5. Don't forget integer division, because 4 divided by 5 will always give you 0. So we divide 4.0 by 5, for example. That will give us 0.8. Then we multiply the 0.8 times 100. Or I'm going to do it this way. I'm going to say 100.0 times count correct divided by 5. And that will give me, if they answered 4 correct, this will give me 80.0, which is exactly what I want. But notice here, I don't want the 0.0. So after doing all of that, I'm going to cast this to an integer. And finally, I need to also concatenate a % sign. Let me run this. I think that's going to work unless I made a mistake. 11, 0, let's miss 1. Let's just print 5 here, and 13. You correctly answered 4 out of 5 questions. Score is 80. That's a fun one to do. Obviously, I'm coding this a little bit faster perhaps, but this one, I hope you paused the video and tried to solve this one on your own. Good chance you solved it differently. Good chance you used a lot of different variable names, maybe a different ordering of things that happened, but here's a particular solution. It should probably match up with what I previously coded of a solution here on the slides. Let's do another one. Subtraction quiz. Let's go. This is fun. I like just coding. Write a program to simulate a subtraction quiz for first graders. Not addition, subtraction. Okay, that's easy enough. Sounds like the same program. It basically is. We're going to swap the 2 generated numbers, num1 and num2, if num1 is smaller than num2, because we want to guarantee that all answers that the first grader will give, we want to guarantee that they will never be a negative number. Maybe they're scared of negative numbers at this point, and they can't say, 2 minus 5, but they can say 5 minus 2. They can answer 5 minus 2. But 2 minus 5 is like rocks their world, right? So we want to just practice. It's just more practice of swapping and using an extra conditional expression to put a Boolean expression to check if num1 is less than num2, then we're going to swap. So because this is so similar to the last program, what I want to do here is say, you know what? Let's now do the better way of generating random numbers. Let's actually visit the random class and show you the better way of making this happen. So Java gives us a random class from which we can make objects of type random. And here's the code. Random RNG equals new random. And break this down. What actually happens? On the right side of that assignment, it says new random. This creates an object of type random. And when we then assign the address of that object into this variable RNG, I call it RNG, standing for random number generator. Call it whatever you like. RNG just makes sense to me. This random object was made from the random blueprint, the random class. And as a result, it has many helpful methods that we can use to generate random numbers. Next int sounds like scanner. Next double, next long, next, or set the seed of the random number generator, which is super helpful at time. So next int, if we give it a bound, it works similar to Python. It generates a random int between 0 and the bound, but not inclusive of the bound. Next double generates a random double between 0 and that given bound, but not inclusive of the bound. Let me open up, if I have it here, yep, tried and true garbage program. And let us test out this random very quickly. Random RNG equals new random. Now, when you use random, that is going to be in the java.util library again. So we need to import it. Let me just type it directly instead of even having NetBeans do it for me. Java.util. Remember, I can do this, or I could just put the wildcard, so therefore I don't need to import scanner or other things. Java takes care of it for me. Cool. Let us now print some random numbers. RNG.nextInt 10. What does that do? That gives you a random number between 0 and 9, inclusive of 0 and 9. I got a 6. Got a 6 again. I got a 0. I got a 7. How about we make it 100? And since we just learned for loops, how about I loop 10 times and I print out 10 times, I print out a random number from 0 to 100. And let's see what we get. I get this. Those are my random numbers. 10 numbers randomly from 0. I say to 100, but it's not inclusive of 100. So from 0 to 99. That's how we can use random. Super easy. I can also put in 2 parameters. I can say make it from 50 to 101, which would be from 50 to 100, inclusive of 100. And what will this give me? Only from 50 up to that number. Or how about from 80 to 101, right? Same concept as what we've already seen in Python. So now coming back, here's a solution. Let's actually see what we can change. So let me just highlight all this code. File, new project, next, subtraction quiz. Delete the package, finish. I'm going to paste my code for addition quiz, which means, of course, I need to change the class name to subtraction. And now what's different? This is the smart way of doing this. Don't recreate the wheel. You've already done the code. Let's see what we want to change now. Well, let's change by firstly throwing in random equals new random. What else do we want to do? We don't want to use math.random for num1 and num2. Now we want to say RNG dot, and we want to call the next int method from 0 to 10. You can do this like that from 0 to 10. It's not inclusive of 10. Or since you're starting at 0, you could have just said 10, which is similar to Python as well. Correct answer is going to be num1 minus num2. The question we're going to ask them is num1 minus num2. That is all going to be the same. But remember, before we check if the answer is correct, or before we ask them the question and determine the correct answer, we need to what? We need to possibly swap num1 and num2 if num1 is smaller than num2. So if num1 is smaller than num2, and what's fun about doing these, all of this code is stuff you know. You are experts at this, in theory. We are experts at this. Let's go. This should be fun to do. But now we have curly brackets. We got these crappy semicolons. but it'll be all right. Num1, is it less than num2? Yes, it is. We need to swap. We've seen the 3 lines of code for swapping. Int temp equals num1, num1 equals num2, num2 equals temp. We've covered that, but if you're kind of like, wait, did we? Am I sure? Make sense of why that works. Think about why that works. Draw it, write it down on a piece of paper. Show those variables moving. See what happens if you just take num2 and save it directly into num1 without using a temp. Well, now num1 has been overwritten, which is why we do this. We need to first save num1 into temp, then we save num2 to num1, then we put temp into num2. But man, it sure does make me miss Python's simultaneous assignment. For those who don't remember, this is how you do that same thing in Python. Oh my gosh, that is some gorgeous code right there. Super easy in Python. Not that it's hard in other languages, but you got a few more lines. Regardless, we have swapped them if needed. And I noticed that random is giving an error saying it doesn't understand it because I did not use the wildcard import previously, which was not good. That's why it's better. Just use the wildcard import. Because otherwise I'll have to come here and manually import java.util.random and import each one individually. Not a problem, but it's just better. You know what? Wildcard, knock it out in one go. Cool. We've swapped them. We have determined the correct answer. We're asking the question. Done. What else did we need to do? Let me see. Come back to here. Is it the same exact problem otherwise? Your results? I think that's all correct. Let me see. Let's run this. 1 correct. 1 correct. 4 correct. Let's miss one. 6 incorrect. 0. Quiz results. You correctly answered 4 out of 5 questions. Let's go. Done. Easy. Not bad at all because we know these things already, right? Let's look at some more easy ones. Write a program that's going to print 10, 9, 8, 7, 5, 6, 7, 5, 7, 6, 5, 4, 3. It sounded funny, right? 3, 2, 1, blast off. I'm not even going to go into detailed problem solving. There's not a lot to problem solve here. We just want to iterate a certain number of times. The purpose here is to practice another for loop, but this time we're decrementing, right? So here we're going to have descending print, file, new project, next, descending printing, delete the package. Don't be scared about making all these projects. They're small in file size. You want to have them for future reference later in the semester, like, hey, how'd we do that thing? All right, let's go. Here, let's make a for loop. Let's try that again. Delete. All right, 4. And I want to loop from what? From 10 all the way down to 1, including 1. So I equals 10. I want to loop down to 1, including 1. So I need to make this greater than 1, and as long as it's greater or equal to 1, right? Or I can just say greater than 0. I'll do it that way this time. And I need to do I minus minus. Now this matches up with what Python would have been. In Python, this would have been what? For I in range 10, 0, minus 1, right? So here's the same thing in Java. And what are we going to print at every single iteration? We want to print the number, which is I, and we want to concatenate to that an exclamation point. Let's make sure this is what we want. Boom. And when we're done, we want to print blast off. Done. Let's go. Let's go. Is that what we wanted? Done. Blast off. Super easy. What about descending print of a string? So what are we looking at? Descending print of a string. Write a program that prompts the user for a string of text. Your program should then print every other letter of that string from the right side, to left, starting from the last, the rightmost letter of the string. Let's read that again. Your program should print every other letter, starting from the right side, right? So if I want to print this word descending, I want to start by printing the G. Every other letter, so print the G, then the I, then the N, then the C, then the E, and we won't print the D. That sounds fun. Let's do this. And when you want to prompt the user for a string, so file, new project, next. Let's call it descending print string. And let's see what we get. Finish. So prompt the user means we need a scanner, right? That's easy. Need a scanner, done. Scanner n equals new scanner. We need to import that, done. After we import, we need to prompt the user. What did prompting the user, let's just say enter a string of text, enter a string, they don't know it's text, enter some text. Maybe the user doesn't know the word string. All right, enter some text, and now we need to just loop over what? Well, it's kind of, you might be thinking the length of that text it is, but since I want to start by printing, let's say this word descending, I want to start by printing the G, and then I'm going to loop down. So I need to know where's that index of the G. Well, that's going to be the length of this word minus 1, right? We've seen that. So I'm actually going to start I at, oh, I didn't scan the word. Let's call it string text equals n dot next line. I'm going to read the entire line of text. So now I'm going to start my loop at text.length minus 1. So whatever length this word descending is, this G is at index length minus 1. And I'm going to keep looping as long as I is greater than 0, because 0 is the first index, right? Keep looping as long as I is greater than 0, but every time we want to decrement minus equals 2. We want to go down by 2, it said. Print every other letter. And so now, let's print this, and we're going to print text.char at index I. And let's see what we get. Let's use the word descending. Descending. Did we do it right? We got a G. Let's zoom in for you. We got a G followed by an I, followed by an N. Let's go. Followed by a C, followed by an E. We got it right. All right, so it's not that bad, but it was funky to think about what we really wanted to do in here, how we started up here. And I don't even like I. I want to change I, which I think it's what I did on the solution as well. What is I? It doesn't make sense. What are we really printing? We're printing the character at a given index, right? So I want to show you, I'd rather call this index or call it IDX as the variable name. So I want to show you also a shortcut in NetBeans. When I click here on I, and I just have the cursor next to I, if I now hit Control R, notice it highlights every instance of that variable I. And so now I can just type IDX enter, and I hit enter, and it changed all of them together, which is super helpful and super cool. So super helpful and super cool. And that's what we got, including some spaces, right? Because we printed the L, the O, and the next thing over was a space, followed by the E, and then the U, and then a space. Cool, that works. That was program 4. Oh, and I apparently put some extra output. The character at index blank is blank. Perfect. All right, that was definite loops. That was using for loops. Now let's do some indefinite loops using while. And here's where we need to get back to that loop design strategy I mentioned. That because sometimes if I give a problem, I've seen learners will think they understand the problem, they do, but then when they try to code it, everything gets to be so confusing, like, I don't know what I'm doing. So I say, let's have a very basic strategy. When you're trying to solve a loop problem, think of what you need to do one time. Forget the loop. Remove that from the equation. Just say, I want to do it once. And then after you do it once and it's working successfully one time, then wrap all of that code inside a while true, which of course will never end, but that's okay. Wrap it inside a while true, run that code, make sure that works even though it never ends. And then at that point, simply add in the loop continuation condition or whatever you need to do to exit the loop. Let's try to apply that strategy on this problem. the number guessing game. Write a program that randomly generates a number between 1 and 100 inclusive. The program will repeatedly ask the user to guess the number until the user gets the number correct. At each wrong answer, the program should tell the user if the guess is too low or if the guess is too high. So number guessing game, here is a sample execution of the program. Enter your guess, 50, guess is too low. Enter your guess, 75, guess is still too low. Enter your guess, 87, now it's too high, so on and so forth. What is this? This is the famous number guessing game. We've seen it in childhood. What's the standard first guess? 50, because it's not about finding the number. Anyone can find the number if you play the number guessing game. You can start at 1, 2, 3, 4, and you'll find the number eventually. The purpose is what? To find it in an optimal strategy in the most efficient, fastest manner. So when you start at 50, what happens, regardless of if your answer is correct, well, if it's too high or too low, you've just split that search space in half, and now there's only 50 more possible numbers, or 49, to examine. So the normal guess is usually 50 as a first guess. Best case scenario, you got it correct. It was a lucky guess. Or it was too high, you have to guess a lower number, or if it's too low, you guess a higher number, so on and so forth. Are we ready to code? You say, yes, let's go. We come here, new project, next, number, guessing, game, and then you delete your package, and you finish, and you come here, let's say you even import your scanner, you make your scanner, n equals new scanner system.in. You import this. Import java.util.star. And you start trying to code the program, and then you're like, wait, I don't know what I'm doing. What do I do? It's confusing. Think before you code. Back away from the keyboard. Remember that strategy. How would we solve this problem without a program? We need a random number between 1 and 100. Oh yeah, that's true. It's not about the guessing. First you need a random number. Oh yeah, I need random. Got you. Random, RNG equals new random. I don't need to import it because I already did the wildcard import. And now I need a random number. Int random number equals new equals RNG.next int between 1 and 100 inclusive, which means you need to go from 1 to 101. So now we have a random number. Cool. What has to happen now? We have to ask the user to enter their guess. Then we have to compare the guess with the random number. And we have to then print, is it correct? Is it too low? Is it too high? Let's do that execution of the strategy, right? Use the loop design strategy, code up one iteration first, and then we test that and see if it works. So what was one iteration? We need to ask the user to enter a guess. So first of all, I'm going to come up here and say int random number guess. Oops, and guess. I want to declare my variables first, so I'm going to get rid of this int. Cool. I'm now going to say guess equals, nope, I need to prompt the user. Enter a guess. And I'm going to make this a print statement, not a print line. Now I'm going to scan their guess. Guess equals n.next int. Done. Now I need a selection block of code. If guess equals random number, they got it. We'll make some print statement. Right? We'll say, great job, or you guessed correct. The number is random number. That works. Put a period afterwards, concatenate a period. Easy. Else if guess is less than random number, if the guess was smaller than the random number, we need to print too low. Try again. And then finally, the last possible scenario, it's either equal, it's less than, or it's greater than. So some people might say else if guess is greater than random number. And we want to then print here too high, try again. There's nothing wrong with this code per se, but in fact, if we're trying to check if two numbers are the same, either they're equal, one is less, or one's greater. There's not a fourth option, right? And so there's no reason for this to be an else if. This really is just else. That's the third option, right? I'll tell you though how I personally like to code this. I like to put a curly bracket here and then put this condition as a comment. Now that's not necessary in this program, but what if you had this was a huge if, else block over 1,000 plus lines of code. When you get down to that final else, you might ask yourself, what the heck is this else even for? You forgot. So if you put it as a comment, oh, the else is checking if guess was greater than random number, then you're good. So here we've done this once. Let's check if it works. Enter a guess, 50, too low. Let's run it again. Enter a guess, 50, too low. Let's keep running because it's a random number. 50, really? Is it always less? Come on. I'm going to wonder if I did it wrong, if it keeps doing this. Let's see. Okay, finally it was too high. I was about to go and start debugging in case I did the code wrong. Finally it says it's too high. I'm not going to keep running it until I get 50 to print this because the chances of that are slim. So it appears to be working. What did I say is the strategy? Code up one iteration. This was one iteration, right? I'm running it. I'm inputting a guess. It's printing too high, try again. That is one iteration. So after you code one iteration, identify all parts of the code that you want to happen again and again and again, right? We don't want to recreate a scanner over and over. I don't want to regenerate the random number over and over, right? I don't want to do any of that. But what I want to do is all of this over and over. So I said wrap that inside a while true loop. So I'm going to put an open curly bracket there, and then right here I put a closed curly bracket. Now the indentation's off, no harm, no foul, Alt-Shift-F, format, auto format. So now run this code. It's never going to exit. It's a while true, but just run it. 50, you get, geez, really? Well, there's that slim chance. Let's run it again. I guess correct. Let's try it again. 50, too low. 75, too high. 62, I'm always going in half. 62 is too low. So now between 62 and 75 is going to be around 68. Too low for 68. Let's go for 72. 72 is too low, so it's either 73 or 74. And here we are, the number is 74. Great, I guessed it correct. But we're still in the loop because it's a while true. Okay, so how do we exit? Well, there's a couple of things. Now that we know that it's working, we just need a way of exiting the loop. We could code this up differently, and you could say while the guess does not equal the random number. That's going to work just fine, except now you need to come hack your way into the loop because at this point, the computer doesn't know what guess is. So we'd have to say guess equals some guaranteed to be false guess, such as -1. That would work. By setting guess equal to -1, we're forcing our way, bullying our way into that loop. And then if guess is ever equal to random number, this gets printed, we come back around, and that will now be a false statement, and we will exit the loop. That works. My preference is this. I just feel it's cleaner to keep this as a while true, and then to come here, and if they're equal, the guess equals the random number, we print, great job, you guessed correct, break. We've seen break before. We know how it works. Let's give this a roll. Let's give this a go. Enter a guess is 50. It's too low. 75, too high. 62, too low. 68, too high. 65, too high. Going to be 63 or 64. And we get 64, and we correctly broke out of the loop. Let's go. That wasn't that bad. We've likely solved this when we learned Python, right? So this is the number guessing game. Program 6, Addition Quiz version 2. Write a program to simulate an addition quiz for first graders. We've already done that, right? But this time, check out what we're going to change. After answering a question, the user should be asked if they want another question. The quiz then stops when they finally enter no. So let's go back to the original addition quiz. Why recreate the wheel? Let us take this original addition quiz, although I want to use the new random, but that's okay. File, new project, next. Let's call this addition quiz 2. Finish. Paste. And let's see what all needs to change. I'm going to make this a wildcard import. I had to rename the class. I need to make a random. RNG equals new random. I need to make these both rng.nextInt from 0 to 10, from 0 to 9 inclusive. rng.nextInt. As I said, you could just put 10. I'll put 0 to 10 just so you can be used to that. Get my correct answer. So now this is not a for loop. It's going to be a while loop, right? So this is going to be a while loop. I'm going to make it a while true. And they're going to, what does it say here? Unreachable statement, because it's assuming, NetBeans is saying, hey, you can't even get to line 27 right now because you have an infinite loop. This is what I love about a compiled language. It's automatically checking that, hey, I got an infinite loop. You got to fix that. Nip that in the bud before you try to run this. It doesn't want to be running an infinite loop. But I'm going to make this a while true. I generate 2 numbers, get the correct answer. So notice here, now when we want to ask them the question, we don't have I, which was, we were using that as the question number. So that means we need to make another variable. I'm going to call it question number. And I'm going to start it at 1, because that is in fact the very first question. And so instead of I'm going to print question number here. If they get it correct, we're going to print correct, and we're going to increment correct. If they get it wrong, we're going to print incorrect. Cool. But now, after we've checked if it's correct or incorrect, now we need to ask them, would they like another question? So do we have, I don't have here a sample. I was hoping I had a sample. Well, we want to ask them, do you want to answer another question? Yes, no. Let's do that. I'm not sure if that's exactly what the solution is, but it'll be close enough. Do you want to answer another question? Yes or no? So now we need to make a string to save their choice. String another question? No. String another question. Notice my tone. That's the purpose of the name of that particular variable. And I'm going to say another question equals n.next. Let's assume the user's not making any errors on input. For the answers, they're inputting ints, and here they're going to enter yes or no as a string. So now I need to say if another question dot equals ignores case. Remember, we can't say in Java, I can't say if does this equal a yes or does it equal a no. I can't check the contents of the strings for that type of string equality. I have to use the equals method. I'm going to use equals ignores case in case they put a capital yes, for example. So if it equals yes, we want to do something, versus if it was no, we want to do something else. So if it's yes, one thing that I know for sure has to happen is what? We need to increment the question number. The question number is going to be question 2, then question 3, and so on. If they say no, they don't want another question, we're going to break. Now the spacing might be off, but let's run this. 1 plus 2, 3. Do you want another question? Sure. So I want to put a space before the question or after putting yes here. If they enter yes, I want to enter question number, and I want to put an extra space right there. So let me hit stop and run that again. 2 plus 8 is 10. Do you want another question? Yes. 6 plus 7, 13. Another question? Yes. Let's put a wrong answer. 4 plus 8, 5. Incorrect. Do you want another question? No. Let's do no. Break. So now we get quiz results. Now I only answered 3 questions. So notice the quiz results. Well, first thing I need to put a new line here before quiz results. Let's do that. I'll put a new line right here. \n. No need for a print statement. \n. And now you answered correctly blank out of blank. Well, I have the count correct, but it's no longer out of 5 questions, right? It's going to be out of the question number of questions. So it's not just out of 5. It's depending on how many questions we ultimately asked them. So I'm going to delete that. I'm going to put question number, concatenate questions. And I need to use that question number here. And I think that's going to be exactly what we want. Let me zoom out a little just so we can see this. 1, yes, I want to do another one. 10, yes, I want to do another one. Let's miss this one. Let's just put 3 as the answer. But yes, I want to do one more. And this will be 7, and no, we're done. I answered 3 out of 4 questions correct. That is 75%. This is perfect. Let's go. We got it right. It is not that bad at all. All right. Do while loop. We want to see, can we do that exact same question, but now with a do while loop instead of just a traditional while loop? And look at what is changed here. Just try to identify here what was changed from a do while loop. Here was the previous code of a while loop. And I want to see what can I change, not what was changed. What can I change from this code of a while loop to make it a do while loop? So here we have a while loop in this code, while true. And how would we make this a do while loop? And I'm not even sure if I want to do that on this one. I may just say, you know what, ignore that slide, because I'd rather on the next question is a more appropriate. Because see, a do while loop here, the only way to force my way into this loop, if I make it a do while loop, like the condition would be, what's the condition of exiting? It's this condition, right? So I'd have to do, you know what, I will make this. I'll make it a do while loop. Do, I'll come down here and we type while, and here's the condition. While another question equals yes, just keep on continuing. This is really the change we make. Do, so a do while loop, it's going to do all of that one time. And then we're going to scan, do you want another question, yes or no? We scan their answer. If it's yes, we increment, and then we're going to print. If it's no, we don't even need the break anymore, because that's going to happen right here now that we put on the condition. That's how we would have changed this particular program to get a do while loop. We have 2 more. Sentinel value. Write a program that will sum up all user inputted values. The user can keep inputting values as long as they wish. If they enter a 0, this means the end of the input. Your program should then display the sum to the user. Here's what we want to see. So I'm going to make a new project, file, new project. And we have, I got rid of the let's go, hit next. Let's call this sum until Sentinel. Let's delete the package and finish. All right, got a lot of projects open over here, no problem. And you know what, let me just show you right now. File, close all, you know what, I'll close them all in a moment. I don't want to close it in case I'll close it, why not? File, close all projects, done. Let me close this too. Save. So now we can go back to that recent project, sum until Sentinel. Done. All right. Sum until Sentinel, we're going to be, once again, working with the user. So import java.util.star. I need to import the scanner. Scanner n equals new scanner. You will be typing this a lot. It's going to be something automatic. We want to do what? Let's follow that strategy. One time we want to do what? ask the user to enter an integer or 0 to stop. So enter an integer or 0 to stop. Colon space, and let's make this a print, not a print line. We need to scan that integer from the user. So let's just call it int val equals in.nextInt. And then we need to add that value to a running sum. Sum plus equals val, which means I need to declare sum above. I'll also declare val above as well, and I'll delete this declaration here. And I need to initialize sum to 0, because right now I'm trying to add val to sum, and if you read this error, it says variable sum may not have been initialized. In fact, it was not. We're trying to add a value to a sum, so we need to start that sum somewhere, and we started at 0. So we ask the user to enter an integer, we scan it, we add that value to our sum, and ultimately when we exit the loop, we're going to print. So this is one iteration. So what can we do? I can take that, I can throw it inside a while true loop, do an auto format, and then I could say if val equals 0, break, right? And then finally, when I'm done, I need to print the sum of the entered numbers is sum. Let's check this out. Let's run it. We entered 4230, 4230. The sum of the entered numbers is 9. Now the purpose of this is to discuss a do-while loop. Here's a while true. So a while true is really a way of kind of doing a do-while loop. Because what does a do-while loop mean? You want to do the entire loop once, and then after you're done, that's when you determine if you should do it again or you should break. Well, for all intents and purposes, that's what this while true is doing, which is a way we can almost substitute this for a do-while loop in Python. We use a while true loop, we do what we want to do one time, and at the end of the loop, before exiting that iteration, we check, hey, should we break? This is effectively simulating a do-while loop. Now, how could you actually convert this to a do-while loop? Well, we're going to take the while. I'm going to cut it out. I'm going to type the word do. And here, after the curly bracket, I'm going to put a space just for visual purposes. I'm going to type, or I'll just paste the while true. So this is still like a while true loop, but it's a do while true loop. And now I'm going to change this condition, because this needs to be a condition here. What is the condition going to be? Continue doing this loop as long as val does not equal to 0. So now we've converted this into a do-while loop, and I can check this, enter 4, then 2, then 3, then 0. Let's go. That was not bad at all. Which loop should you actually use? Because sometimes, we're a bit confused. Do I use a for loop? Do I use a while loop? When do I use one versus the other? I'm not so sure. Well, it really depends on your purpose. You could say based off of your preference. But a while loop and a for loop, these are pre-test loops. These are loops where you're going to be checking the condition before you even iterate the loop one time. That very first iteration, you may not even execute it with a while loop or a for loop. Whereas a do-while loop is a post-test loop where you're going to iterate that loop guaranteed at least one time. All of the loops accomplish those same goals, but it really depends on your comfort level and what you like to use. A for loop, you should know, you use it when you know definitely it is a definite number of repetitions. That's why it falls under that definite loop category. A while loop we use when it's unknown. I don't know how many times I need to loop this thing. That's also when you use a do-while loop with the slight nuance or difference between them, that we use a do-while when we know we want to execute it at least one time. All right, nested loops. A loop can be nested inside another loop, as we've seen. And you can keep that nesting. Keep doing it over and over and over. Let's pull up the famous garbage project. check this out. I can keep nesting, and there's no limit. Here I'm going to loop 10 times. Here I'm going to loop another 10 times. Here I'm going to loop another 10 times. Let's do it one more. Notice the variables automatically change from I to J to K to L to M to N. Dear Lord, how many iterations would this be? 10 times 10 times 10 is 1,000. 10,000, 100,000, million times. If I ran this, it would try to increment. Let's increment a value. Int sum equals 0, and let us increment sum. This is going to be nasty, but 1,000,000 times isn't that bad. Let's print sum, and let's see what we get. I've never done that. Yeah, that's not, 1,000,000 iterations is pretty fast for a computer. You make it 10 billion, a trillion, then we're going to have issues. So this can get bad very quickly, though. What if I had just a lot of zeros? I said, let's iterate this 1,000 times, and let's iterate this one 1,000 times. Now you're at 1,000,000 iterations. Well, now you're at 1,000,000,000 iterations if you said sum plus equals or sum plus plus. That's going to be problematic. Run this one. That's going to be faster, but I promise you, you make that much larger, you're going to have challenges. And so we have to be careful as well know that nested loops, there's a lot of iterations that take place in nested loops. We have multiplication table now. Using nested loops, write a program that uses nested loops to print a multiplication table. And I want to see, was this the last one? Yep, that's it. Last one. Let's go. Multiplication table. I am excited. Let's make this happen. So here, we want to print this using nested loops. How can we do that? File, new project. Next, multiplication table. Delete the package as always. Finish. All right. We don't need to interact with the user. There's no need for a scanner. There's no need for a random. We just want to print. We just want to print. What do we want to print? We want to print this stuff. You should see we have 9 rows. Every row has 9 columns. Every row has 9 cells of data. So let's start by just trying to print 4. I want to loop from I equals 1 to 9. And I'm going to change I to be row. I want it to be row. For row equals 1 to 9. For, let's call this call. For call goes from 1 to 9. But let's make sure it's less than or equal to 9. And let's just print. Oh, no, let's just print row times call. But we want to be able to print row times call with some space and on the same line, right? So I want to print on one line. I want to print row times call plus, let's put 4 spaces. And then after that row, let's just print a new line. We'll discuss this in just a moment. So here, check this out. It's not going to be perfectly spaced because we haven't learned formatted printing yet. But let's see if that's what we want. Let's make sense of this. On row 4, for example, how do I get this value here? I want to print 4 times 1. How do I get this value? 4 times 2. 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7. Well, that's what I'm doing here. I'm looping over every row. So now when row is at 4, index 4, now I'm going to loop over all columns of that row, and I'm going to multiply 4 times 1, then 4 times 2 when column becomes 2, then 4 times 3 when it becomes 3, then 4 times 4, then 4 times 5, then 4 times 6 when it becomes 6, right? I'm going to loop over all columns from 1 to 9, multiplying 4 times 6, 4 times 7, 4 times 8 right here, no, right, 4 times 8 right here, 4 times 9, 36. After I print 4 times 9, what do I want to do? I want to finally print a new line because all of this was on the exact same line. So here I want to finally print a new line to go down to the next row. So here's just a preview because this doesn't look pretty. So a preview, formatted printing. This is really going to be %d 4d, which is over 4 spaces, and I'm going to do row times col. And that will print for us a nicer looking table of that data. That's how simple it was to really just print the data inside the table. What remains is to print, okay, well, on each row, before I print the actual values of the multiplication, I need to print the actual row number. Not a big deal. I could come right here and print without a new line, just print, okay, I want to print row plus, it was a vertical line, right? We print a vertical line like this, no big deal, and we get that. What remains is we want to print this header row as well. That's just spacing, and it's just other stuff to print before we even print that table itself. So I'll come right here for, this is going to, like, let's make it col from 1 to 9, less than or equal to 9. And we want to basically print the column value. Let's print on one line. Let's print column, I think it's going to have spaces beforehand. Yes, print 1, 2, 3, 1, 2, 3, column. And let's print a new line afterwards. And let's see what we get here. That actually looks pretty good. Is it the 8's right there? That looks good. So I need some spacing beforehand. Just one off. Just some spacing. I think it's going to be maybe this many spaces, or is it going to be one less? Nope, one more space. One more space. That looks good. And finally, I need this just line of hyphens. Right? After that, I need a line of hyphens. That's easy. I don't know how many. I could do it a more sophisticated way, but oops, I'm one off. That is super simple. Done. Here is the table. We simply finish this by printing the header, multiplication table. So the main thing, though, that I think a lot of students have when dealing with solving this problem, even if they've seen nested loops before, is wrapping your minds around what's going on. Like here that we're looping over all the rows, and then for each row we're looping over these values and performing multiplications and printing them. That's the hardest part. And to be fully clear, full transparency, there's only one way to get through that and get better at it. And that's to answer this question of what is remaining. What's remaining is practice. A lot of practice. You gotta kick the ball. I say here, when you're done practicing, practice more. The more you practice, the more you do these nested loops, the more you practice any of these problems, you're gonna get stronger and stronger and better at this. It has been fun. It has been a blast. Let's go. We're done. Loops. Leave a comment. Ask questions. Take care.